we have to withstand an audit because UL, TUV, they will periodically send a representative to the factory, and they'll go out on the floor and they'll look at a product and they'll check the listing report and look and see exactly what component has been installed to make sure that it matches up. And they have the right to review your records to make sure that you have it under control. So the process control in manufacturing here is key. If you've got a system where you don't really remember who you bought the parts from last year when you bought them, um, that's not gonna fly in an audit. They're gonna want to see certificates of compliance to specifications that you've written that identify that UL is in control of this part, or they're going to want to see a mark on the product that it is in fact UL recognized or UL listed, and that's just UL. So those are the typical things. They'll come in and they'll say, well, we want to see UL listing marks on A, B, and C, and UL recognized marks on these others. And because in some cases they say you can use any part you want so long as it's UL recognized. And that's great. But then they can go back and audit, hey, what did you put in this last month? We have to come up with a part number and identify the part by manufacturer and part number and show that it was UL recognized at the time we put it in. So,
And this is, yeah, and this is all like a traceability kind of thing, because you could take a product to a regulatory body and get it certified, right? But then once you leave and you go to manufacture this thing, there's really nothing physical that says you can't just go out and buy whatever power supply you want and put it in there. So the other side of the regulatory is they certify the product, but then they also check that you're adhering to what they certified. And that's what John's talking about with these audits. They will literally randomly walk in our door and say, hey, I'm here. I need to check out all your records for this product. Or I want to spot check that you're using that component on this product. And that's their way to check our adherence to the certification that was given to that product. So they can come in and they can say, all right, well, we certified that you're using this power supply because it's rated for X, Y, and Z. Can you provide me the traceability, provide me the evidence that says you're using this power supply on every product that rolls out the floor? And at that point, we would go back through our purchase order history, our receipt history, our incoming inspection history, all the checks and balances that we've got in place to give the auditor confidence that what they certified, the component that they certified is the one that shall be used in the product, is the one that we're actually using in the product. It's all that traceability and record keeping.
So first, you need to get the product's design approved. We would submit products, they would do testing on the products, and they would decide, yes, this product meets all of these standards. And then typically they'll want to approve the factory. They want to know where is it going to be manufactured, and they'll come into the factory and make sure that the factory has the kind of process controls in place to ensure that the parts that they've specified will be the only ones that are installed in the product. And then periodically they'll come in and do an audit of the production line to make sure that your processes remain under control. And when they see a quality standard like ISO 9001 or ISO 13485, both of which we have, it certainly shortcuts the process. They can lean on the third-party certification of our quality system as evidence that we have the thing under control. And it's an auditing process. So they'll pick a unit or two and they'll poke into it, and if everything lines up and everything looks good, we're good to go for another 3 months. And sometimes they come in once every couple of years. Sometimes they'll come in once a quarter, depending upon who it is and what the risk involved is. So our clients in many cases hire us to get the approvals through the test lab, which is one thing. And if we're manufacturing it, it makes it easy because we can easily implement whatever controls is required for the product. Although they are auditing product resources to make sure that we are complying their uh, with their requirements, it's also a reflection on the customer somewhat because the customer can give an ECO, an engineering change order, and say, okay, this part is too expensive. We're going to a less expensive one. If that part is on the critical materials list or in the listing report for regulatory approval, we've got it flagged in our QMS system, and it'll at least trigger some questions. Is the new part suitable as a substitute? And we need to be absolutely sure that it is. If the requirement is it must be UL recognized and the new part is UL recognized, we can say, yeah, it's a suitable replacement and we can make the change. If it's not, then we have to say we can't make the change because UL requires a recognized component and this one isn't. Doesn't matter how much cheaper it is, you can't put it in the product. And there's not usually a battle. I mean, whoever decided to make the substitution says, "Oh, shoot, I forgot," and goes back and finds one that is properly rated. We say all the time, getting regulatory approval is not a box to be checked. It is a process to be followed. And it's a little subtle, hey, it passed regulatory approval, champagne for everybody. That's just the start of it. That just gives you permission to keep the product under control.
Right. And once you're certified, it's important to realize that once a product has been certified, that product, that thing that went to the test lab is the thing that got certified. So it's our job as a manufacturer to adhere to that design. And everything that we just talked about, this critical materials list allows us to adhere to that design in our manufacturing process and ensures the traceability for every component to make sure that we put it together as it goes through our process, and every one that ships out is the same. The first one's the same as the 100th, is the same as the 1,000th, is the same as the one that got certified, and all of that traceability through. We have a bunch of products. We have one product that we've been building now for 8 years, and we have the traceability of every component on every single product that we've ever shipped. If somebody really wanted to go digging, they could say that unit that you built on February 12th of 2017, I want to know everything, every component that went into it and where you got it and the part numbers for all of them. And
Yeah.
It would take a little work, but we could dig through and find that information.
Sometimes UL requirements are a little bit more stringent. Sometimes, say, EU requirements are a little more stringent. So we get it certified to both by using the most stringent for every test. And then you can put both marks in the product and it can go either place. I don't think that we've had a case where we sell one product in the US and another one in the EU.
Yeah, and that comes back to, like John was saying earlier, if we know what markets our customer and the product wants to serve up front, that helps drive the design. So to your point, like if we have a product that we know is going to be sold in Europe and the United States, well, the big one right there is the voltage that comes out of the wall. In Europe, it's different than it is in the United States. So that lends itself to how we design our product. And like John said, we're more stringent. We pick the most stringent standard and we design for that. handling everything under it. Sometimes, I mean, I'm trying to think of an instance. I guess the only thing I could think of would be the Argent, where we have two different. It's the same product, but it's got two distinctly
Yeah,
different.
in some cases, you can't use universal AC voltage. With that means you take anything from, say, 90 volts up to 265 volts at 50 or 60 hertz. So that covers you pretty much worldwide. But the product has to be designed to take that wide range of voltages. And if you have a product that has, say, one component in it that is either 125 volts or 250 volts, but not both, now you've got to bifurcate the product because you've got to put one component in one product and a different component in another product. You can do it. There are other products where you flip a switch to set it from one voltage to another. And it's much more desirable to have, because modern power supplies, they switch easily between all of the voltage ranges. But if you're not using a modern power supply, if you're using the AC, then sometimes you have to have transformers that are wired a little bit differently, depending upon what voltages and are required within the box. So it all depends on the product and how it needs to be, what its electrical requirements are. When you go to launch a product, you better be pretty certain that that is the product that you want to launch, because if you get a beta prototype approved for shipment, and then now we're going to design the real one, and you make a whole bunch of changes because, hey, you're an engineer and there's always a way to improve it. It's not the same product that was reviewed by the lab, and it's up to the group whose logo is on the label, like UL or TUV. They're the ones that get to say, yeah, okay, those changes, that sounds pretty good. Send me some documentation, no problem. Or no, you need to send us one so that we can look at it. The changes are too complex. We need to do another hazard analysis or something on it just to make sure that something hasn't changed. Some changes are very easy. It's a paperwork exercise. A paperwork exercise, by the way, still costs $500 to $1,000 because they've got to open a file, write a bunch of reports, get them into the file, get all the approvals. It costs money, even for minor changes to things that are on that critical material. But it might be more extensive testing depending upon what was changed. So the way to handle that is when some product changes are planned, we try to decide, is this going to affect the certifications that the product has or not? And if it is, we gather whatever documentation we need and we go as early as possible to the test lab and make them aware of what's going on. And then they'll decide if they need an approval cycle. Worst case is, oh, there's an approval cycle, send us one. So we'll build them a new one with the changes in it and we'll send it. But we'll continue to manufacture the old version until the approvals come in, and then we can switch over. And if the customer doesn't want that, then there can be a gap in production while we're waiting for the approvals.
Okay.
Because we can't ship out of our building. We can't ship with a labeled product out of our building unless we know that it's in full compliance with the standards that are in effect at the time.